Alright, this video is going to be on what a function is and then how to evaluate a function. So a function is a relationship between two values such that each input has exactly one output. And the inputs are x values, the outputs are y values, and what that means is that a function is predictable. If you plug in the same x, you're going to get the same y every single time. You're not going to wonder which y value you're going to get. It's very predictable. They pass the vertical line test. So the vertical line test is kind of how you can graphically check this out and make sure that it fits. And typically with functions, we use the notation f of x, which is the same thing as y. And if you don't think you'll remember how to say that out loud, we can go ahead and write that down. So you say f of x. That's how you pronounce it out loud. So a couple examples of functions. I'm going to give you guys some graphic examples as well as some algebraic examples. So here is a graph that's an example of a function. The vertical line test just says if you put your pencil across the function, it will only touch one point at a time. So here's another example. This is a parabola. Again, it passes the vertical line test. Some non-examples, or graphs that would not pass the vertical line test, could be like a circle. On the very edge of the circle, I can see that it's okay because only one point is touching my pencil. But if I put my pencil in the middle of the circle, it's touching two parts of the circle at the same time. The same would be true if we're talking about a parabola that has been flipped on its side like this. So here, again, at the vertex, it's okay, my pencil's only touching one point. But if I move my pencil over, I can see it's touching 2 points of the graph at the same time. So for some algebraic examples, let's say we have the equation y equals x squared. That's a parabola, so that one would be okay. Y equals the square root of x, that's okay. If I plug in an x value, I'm going to get a specific y value. So whatever x I plug in, I get only one answer. Now down here, a non-example would be if I had plus or minus the square root of x. That would be a problem because I have multiple y values that go with one x value, and that's an issue. And then as far as tables go, we might see something like -3. If I plug in -3, I get 2. If I plug in 4, I get 1. If I plug in 7, I get 1. This is okay because it's predictable. Whatever, if I plug in 4, I know I'm going to get 1 every single time. For a non-example, if I plug in -3, I get 1. If I plug in -2, I get 5. If I plug in -3, I get 6. And this is not a function because sometimes if I plug in -3, I'll get 1. Sometimes if I plug in -3, I'll get 6. It's not predictable. All right, next. Polynomial functions are functions that look like this. And they are in the form, we're going to write this right underneath where it says degree. They're in the form y equals, or you could write f of x equals, and it could be ax to the third plus bx to the second plus cx plus d. Or you could go through and change that polynomial function to have a different exponent. It could be to the 7th power, it could be to the 11th power, it could be lots of different powers, but these are kind of typical polynomial functions that we'll look at a lot. And the degree of the polynomial function is the highest exponent. And that is a good vocabulary word to know just because it shows up every so often. Somebody will ask what the degree of the polynomial was, or they'll reference that in the context of doing something else. So that's good to know. All right, so now that we know what a function is and is not, we want to know how to evaluate a function. So when you guys were back in your Math 1 classes, they might give you a problem like this and say, if you have the equation y equals 3x plus 2, and we want you to find y when x equals 5, how would you do that? And so if you want to find y when x equals 5, you would say y equals 3 multiplied by 5 plus 2. And that is 15 plus 2, so we would say y equals 17. And if we put those two things together, we could look at a graph, and on the graph we would see the point 5, 17. That would be something that was on the graph. So evaluating the function is going to be the same, it just has notation that's a little bit different than what we're used to. So this function tells us that x is what the independent variable is. It's saying the function is related, it's based off of x. So here it says, instead of saying y equals 5, they're going to say find f of 5. They're going to say use that x value of 5. So I would say f of 5 is 3 times 5 plus 2. So again, f of 5 equals 17. Now the cool part about function notation is you don't have to come at the, after you've done the problem and say, okay, in conclusion, this gives me the point 517. You can look at it and see the point already. The x is 5, the y is 17. So part of the notation tells you what number you've plugged in to get that answer. That's kind of cool. All right, here's the next one we're going to look at. Let's say we want to find f of negative 3 of this equation right here. So I'm going to say f of negative 3 equals negative of negative 3 squared plus 2 over negative 3 plus the absolute value of negative 3. All right, so first I'm going to say negative 3 squared is 9. So negative 3 times negative 3 is positive 9. And I have a negative in the front, so this first number is negative 9. 2 divided by negative 3 is the fraction negative 2/3. And then on the end, I have the absolute value of negative 3. So that's asking me how far is negative 3 from 0. And the answer is it is 3 spaces away from 0. So I'm going to ignore the fraction for a second. If I have negative 9 and positive 3, that gives me negative 6 overall. So I have negative 6 minus 2/3. So if I've got negative 6 and negative 2/3 all together, that makes negative 6 and 2/3. And of course, you could have plugged that into your calculator, but it's not a bad thing to be able to do it in your brain. All right. And then over here it says f of q. So f of q. So I'm just going to take, I know that q is what x is being evaluated for. So that means anywhere I see an x in the problem, I'm just going to replace it with a q. And since I don't know what q equals, that means that I'm done.